This is the A8 Graphing Quadratics Level 2 video. So finding key components of quadratic equations given an equation in vertex form or standard form. Okay, so we'll see quadratic equations in two different forms in A8. So standard form, which is y equals ax squared plus bx plus c. And it doesn't matter whether we write y or f of x. More often than not, we'll see f of x. Or vertex form, which is a x minus h squared plus k, or we'll see it as f of x. Oops. So just like in Algebra 1, where we were given three different forms of linear equations, in Algebra 2, for quadratic equations, we'll see a third form later, but for right now, we'll deal with just these two, standard form and vertex form. Okay, so each quadratic function has a standard form equation and a vertex form equation, just like a line would have a point slope form and a slope intercept form. Okay. Pause the video if you need more time. Okay, so both of these forms will be useful in different ways. It will be important that we know how to use both of them. So we'll take a look at standard form. We will be asked to find the y-intercept, vertex, axis of symmetry, and the standard or vertex form of a particular equation. At this point, we do not know how to find x-intercepts given a quadratic equation, and we'll learn how to find x-intercepts in A9 and A10. Okay. So finding the y-intercept. So remember, a y-intercept is where a function crosses the y-axis. So let's take a look at this graph. So what is the x-coordinate at the y-intercept? So I know my y-intercept is right here. My x-coordinate, so for this ordered pair, I go over 0 units and I go up 3. So my x-coordinate is 0. So that means in order to find the y-intercept, we must set x equal to 0 and solve for y. I'll put in parentheses here, or f of x, because we can use them interchangeably. Okay. Pause the video if you need more time. So let's find the y-intercept of these quadratic equations. So I'm given f of x here, so I'm going to plug in 0 for x. So I have 2 times 0 squared plus 16 times 0 plus 30. So 0 squared is 0, so I have 2 times 0 plus 16 times 0 plus 30. So I know 2 times 0 is 0, 16 times 0 is 0, and then I have my plus 30. So I know my y-intercept is 30. Just a little hint here, if you're given an equation in standard form, if you're trying to find the y-intercept, you're always plugging in 0 here and plugging in 0 here. So once you do that, This term cancels out and this term cancels out. So in standard form, your y-intercept is just whatever your c is. So I have plus 30 on the end here. 30 is my y-intercept. Okay, that is just for standard form. Okay? So now I'm given an equation in vertex form. So I'll do the same exact thing, plug in 0. So I have 0 minus 2 squared minus 2. Okay. 0 minus 2 is negative 2. Negative 2 squared, so negative 2 times negative 2 would be positive 4. And my minus 2 comes down, so 4 minus 2 is 2. Okay, pause the video if you need more time. Okay, so finding the vertex. So when we are trying to find the vertex, we're looking for the ordered pair h, comma, k. So we need to know how to find h and k. Okay. So when given a standard form equation, as it turns out, which we don't know at this point how to find the origins of h and k, it turns out we do something called completing the square, which we don't learn until A10. So we'll go over that when we cross that bridge, but for right now I'll tell you that h equals negative b over 2 times a. Okay? And we get the b from our standard form equation, we get the a from our standard form equation. Okay? And then k is f of h. So all that means is we're going to solve for h, okay, so negative b over 2a, whatever that is. Take that h and plug it into our function. Okay? So when given the vertex form equation, our h and k are already identified. Okay? The vertex form can be written as f of x equals a times x minus h squared plus k. So if you're given an equation in vertex form, you have your h and you have your k. Okay? Pretty easy. We just need to be careful of the sign of our h because for this general form, it's x minus h. So if we happen to have x plus 2 here, our h would be the opposite of plus 2, so it would be negative 2. Okay, we'll take a look at it, a couple examples right now. Pause the video if you need more time. Okay, so find the vertex. So I'm given an equation in standard form. So to find my hk, I know h is negative b over 2a. So negative b. So I know my b is negative 2, so I need negative, negative 2, or the opposite of negative 2. So I get 2 and 2a, so 2 times whatever my coefficient of my quadratic term is here. So it's a 1. So I get 2 over 2, which equals 1. So now to find k, I need to find f of h. Well, I know my h is 1, so I'm just going to plug 1 in for x up above into my original equation. So I get 1 squared minus 2 times 1 minus 1. So I get 1, so 1 squared is 1 times 1, so 1 minus 2 minus 1. Okay. 1 minus 2 is negative 1. Minus 1 would be negative 2. So I know my vertex is the ordered pair 1, negative 2. Okay, so now I have a vertex form equation here. So I'm given my h and my k. This is my h, and this is my k. So I know my vertex is at 1, 3. As easy as that. Pause the video a few more times. Okay, so finding the AOS, or the axis of symmetry. So the axis of symmetry is determined by the x coordinate of our vertex. So if you take a look at any quadratic equation or any parabola, it can be shifted left, right, up, or down. The axis of symmetry is the vertical line that goes through our vertex. Therefore, the axis of symmetry is found by finding h, okay, and writing it as a line, or the equation of the vertical line. Okay, so we have x equals h, okay, and since h equals negative b over 2a, I'll just write it both ways right here, okay? So if we find the axis of symmetry of these quadratic equations, I need to find what h is. So h is negative b over 2a. So negative b, so I need the opposite of negative 6. So I get 6 over 2 times my coefficient here, which is 1. So I get 6 divided by 2, which is 3. Okay? So looking up above here, my axis of symmetry is the line x equals 3. Okay. Now I'm given an equation in vertex form. So I'm given my h, I'm given my k. Again, I have to be careful with my sign here. I'm given x plus 4. So I know my h is actually negative 4. It's just the opposite. So because of that, I know what h is. So that'll be my axis of symmetry, the vertical line x equals negative 4. Pause the video if you need more time. Okay, so now we're going to go from standard to vertex form. So for a few problems, or for the majority of problems in this level of the standard, I'll give you a standard form equation and tell you to put it in vertex form. Or I'll give you a vertex form equation and tell you to put it in standard form. So the obvious difference between standard and vertex form equations are the h and the k. So we need to find h and k. Okay. Then all we have to do is plug in h, k, and a. And the a is the same in both standard and vertex form. So what I'll do here is I'll just write both the equations for my standard and vertex form again. So standard form is ax squared plus bx plus c. And vertex form is a times x minus h squared plus k. So I'm given an equation in standard form here. So I need to find h and I need to find k. So I know h is negative b over 2a. So negative b, so my b is negative 4, so I need the opposite of negative 4, which is 4, over 2 times a is 2. So I get 4 over 4, which is 1. Okay. Now I need to find k. So k is just f of h, so I'm going to take my h, which is 1, and plug it into my equation up here. So I get 2 times 1 squared minus 4 times 1 plus 1. So 1 squared is just 1. So I have 2 times 1 minus 4 times 1 plus 1. So 2 times 1 is 2 minus 4 plus 1. So 2 minus 4 is negative 2 plus 1 is negative 1. So I have my h, I have my k, and I have my a, which is just this 2 right here from my original equation. So for vertex form, I'm just going to plug everything in. So my a is 2, x minus, my h is 1, don't forget the squared, and then my k is negative 1. So that is the vertex form of this equation. So I know if I were to graph this equation right here, which we don't know how to do yet, but if you were to plug it into some type of graphing utility, if we plug this equation in and this equation in, we'll get the same parabola, or the same quadratic function. Pause the video if you need more time. Okay. So now, going from vertex to standard form. So going to vertex to standard form is actually very easy. All we need to do is FOIL distribute and combine like terms. Okay? So, I'm given an equation in vertex form. To put it in standard form, let me rewrite it. So instead of writing x plus 2 squared, I'm going to expand that as x plus 2 times x plus 2. Then of course I have my plus 3. So when I FOIL this, I get x squared plus 4x plus 4. And I have my plus 3. So I've FOILed. Now I need to distribute whatever my a is. So I just have a negative 1 here, or negative sign. So when I do that, I get negative x squared minus 4x minus 4, and then this plus 3 tags along. So I know my standard form equation here, I have to combine like terms, is negative x squared minus 4x, and then negative 4 plus 3, which is negative 1.